get access to hundreds of PDFs with drawings like these and typed out explanations. I'm not going to go over glycolysis by naming all the reactants, products, and enzymes. Instead, I'm going to highlight the things that are not quite as obvious but still important to know for the test. First, I'm going to point out the really important steps and why they're important. Hexokinase is one of the irreversible steps, as is phosphofructose kinase 1 and pyruvate kinase. Phosphofructose kinase 1 is also the rate limiting step, which they really like to ask about. Aldolase is another important step because it splits that molecule into two molecules, so every step after that is happening to two of those molecules. Glyceraldehyde phosphate dehydrogenase is one you really want to know because it produces NADH. And lastly, make sure you're really good on every step that involves the production or the consumption of ATP. Now we'll look at some ways that glycolysis is regulated. The most important regulator by far is fructose 2,6-bisphosphate. During the fed state, insulin is released, and it's going to activate phosphofructose kinase 2, which is present in the liver. That causes some fructose 6-phosphate to get converted into fructose 2,6-bisphosphate, and then fructose 2,6-bisphosphate comes down here and activates phosphofructose kinase 1. The opposite's going to happen whenever glucagon is released, because glucagon will make this kinase actually act like a phosphatase, and it's going to do the opposite that the kinase does and remove the same phosphate that kinase was trying to add. That will turn the fructose 2,6-bisphosphate back into fructose 6-phosphate and stop that activation of phosphofructose kinase 1. So insulin indirectly activates glycolysis by creating fructose 2,6-bisphosphate, and glucagon indirectly inactivates glycolysis by getting rid of fructose 2,6-bisphosphate. For the rest of glycolysis regulation, you're pretty safe to just follow the rule that anything glycolysis produces is going to inhibit glycolysis, and anything that glycolysis uses as a reactant is going to promote glycolysis. So your common inhibitors are things like ATP, NADH, and your common activators are things like ADP and NAD+. The only specific ones that I'd really worry about is that glucose 6-phosphate inhibits hexokinase, and then ATP inhibits phosphofructose kinase 1. But in general, if you follow this principle, you're going to be fine. The last thing we'll look at is some molecules that can relate to glycolysis but are not directly in the process. First, when glucose 6-phosphate is produced, some of it is going to get shuttled out to be put into the pentose phosphate pathway. Some of it will be used for nucleotide synthesis, but the glucose that isn't used up will get turned into fructose 6-phosphate and re-enter glycolysis. Next, some of dihydroxyacetone phosphate, or DHAP, will be used to create glycerol, which is then used to create triglycerides. And that's going to help us store fat during the fed state. Then during the fasting state, those triglycerides are broken back down and we use those fatty acids for energy, but we're left with a glycerol backbone. That glycerol backbone can then go to the liver and get turned back into DHAP to feed into gluconeogenesis. 1,3-bisphosphoglycerate has a special thing that happens to it. In red blood cells only, some of them are going to have this phosphate group moved over to the hydroxyl group that's on carbon 2 and become 2,3-bisphosphoglycerate. 2,3-bisphosphoglycerate is then going to lower the affinity that hemoglobin has for oxygen and help release it. This is mostly important just during pregnancy because it's going to help release oxygen from the maternal hemoglobin to then cross over and go to the fetal hemoglobin. Lastly, pyruvate will sometimes turn into lactic acid via lactate dehydrogenase.